discussing a presentation about robot learning from humans. The link's in the show notes. I think he's assistant professor at Georgia Tech, and he did his PhD with Fei-Fei Li. So the idea here is that you want to learn from humans, and the question now, how do you do that? And also, why is that so important? Some scientific questions and some practical engineering questions. So it's a pretty interesting presentation. I think fundamentally, the way we see, this is us now, Orange Capital Partners, the way we see the robotics pipeline evolve is very similar to the self-driving pipeline. So we're going to learn from humans. We're going to collect a massive amount of human data, and then we're going to learn from them. We're going to augment this data set with, with generated data, with simulation data, and then deploy a fleet of robots, and then also find ways to learn from the robot fleet. I'm going to talk about all these things. Some of these things are discussed in this presentation, but most of it is our views. I want to use this presentation as a, as an inspiration, let's say, for our thoughts in general about how we see the robot pipeline. So let's first talk about the presentation. So the core problem is, how do we learn from human data? And the solution is, we put cameras in humans, and we have them actually do, we have them do real actions, whether that is in the context of whether that is in the context of, like, let's say, actual worker doing actual work, or this could also be somebody doing, just tasks, so to collect the data. There's some interesting comments that I didn't know that that's happening. For example, Doordash is putting cameras on people. In general, there seems to be an opportunity to make money by putting cameras on and just executing tasks at a job. So just augment your pay that you get, or even just do the job for data collection. There is Scale is involved in this, of course, the data collection company, and then Meta and others are involved here. It's pretty interesting. Meta has the glasses, so that's an interesting angle here. They could use the glasses and have people record stuff that they do and then collect the data. So that's probably what Meta is trying to achieve here, and that's actually a pretty interesting aspect to the whole robotics pipeline. It's what Meta is trying to do here is kind of like what Tesla did, right? Sell access or sell something that people actually use, and then use that and generate the data set that actually is the product here, which is going to be AI. So that's the idea. Actually, it's pretty interesting. I didn't think about this per se. I mean, I just saw the head of Meta glasses last week at a seminar at Stanford, and that never came up. It's my feeling that he probably doesn't even know that is the goal of the Meta glasses. But again, this is the Tesla model, right? FSD. So you sell cars with cameras, people drive around, you collect the data, and then you find ways to train from that data. So that's one aspect which I think is super interesting, and I wouldn't underestimate Meta in this from this perspective. I don't know what exactly they might want to do with this data, since Meta, I don't think, wants to enter the robot market, but they could be using it for augmented reality and things along those lines. So that's one interesting thing. I think the other thing that he mentioned is the idea that once you have, let's say, human data from actions, you want to be able to predict human actions from the data. So that is a good proxy for the quality of the model, which I thought was interesting. But then the main problem, and he didn't talk too much about this, but it's the translation, closing the morphology gap. I think we spoke about this just recently in the context of Jitendra Malik's presentation. So you want to close the morphology gap between humans and robots. Another thing he mentioned also, which is super interesting, is that you have what you want is a lot of diverse actions, and then put them in latent space, and then there seems to be emergent learning in latent space from all these diverse actions, which I think that's not surprising. I think we've seen this before in other contexts with RT1, RT2, RTX. So basically, what you want to do is you want to have a lot of diverse. You want to have a lot of diverse tasks being executed by humans. Now, in principle, let's go a step back and just think about philosophically what's going on here. First, the answer to the question, why are we even using humanoid robots? I think one of the answers is because we have a form factor, which is a human, that helps us collect data, right? Because we don't have large scale deployments of all kinds of different types of form factors, but we have one form factor. If we just consider the human as just a proxy to a robot, we have a lot of information about how humans execute tasks, how humans move. So therefore, it is actually pretty interesting and useful to think about having a human form factor. Now, it's not exactly a human, but it's close to a human, and that's the morphology gap, and that can be closed. Now, the most important problem, of course, is to go from video, which is sort of a two-dimensional, it's three-dimensional, four-dimensional, so 4D video data into actual, robot data. So this translation is, it's an engineering problem because this translation can be done. I mean, this is sort of a mathematical transformation. Think of it like a Laplacian or something along those lines, where you take an action by a human, you record it in video, and then you translate the action in latent space, and then the robot can use the parameters from that action and execute something in latent space or in simulation, and then translate that into the real world. I mean, sim to real. So there is definitely a morphology gap and a sim to real gap to be closed here. But I think we've seen approaches in this presentation, also in Jatindra's presentation, that gives us enough confidence that this gap can be closed. Now, I want to just add a few things, our own thoughts to this presentation in general, to the robotics problem. I think what's interesting about the robotics problem is the data problem. And I think the more we think about it, the more we look at the sort of interesting approaches, the more this problem actually is turning into a challenge and an opportunity. And I think the opportunity is a learning from video. First, we have actually a data set, a scaled data set, internet scale data set of human action videos on YouTube and other. There's plenty of videos of human. I mean, almost every YouTube video has humans in it. In fact, we can even throw in their animals, and then we have even more. And of course, the morphology gap for animals and humans is pretty large. But in latent space, for example, the navigation problem of a cat and a robot are in latent space relatively similar problems. So I'm not super familiar with the actual engineering intricacies of that, but I have a feeling that you can use even non-human videos as long as there is movement and action, and that was Jatindra's actually interesting insight. We have navigation and locomotion, right? These two are substrate independent, and then the manipulation, the actual execution of a task, for example, that of course depends on the actual morphology of the form factor. But again, I think we believe that the ability to learn from video is the crucial part here. Now, this can be augmented with actual real human videos that are trained, whether that is in that Doordash context or, meaning you actually deliberately generate videos with humans. I've thought about this several times. Let's say you could give the Meta glasses to Starbucks employees, and they could be recording their actions. So So there's a lot of opportunity on that front, and some of it is being taken already. So that's interesting, and I think that's a very interesting sort of tidbit to follow and see how that's evolving. So this idea that you put cameras on people and have them execute tasks and actually collect that data. And then the next step, I think the even bigger step then is to learn how to train, to learn how to train from generated video, right? So once we have the human video, whether it's human videos generated deliberately for training or just human videos in general from YouTube, we can use those to create a generation engine, so a video generation engine that then generates videos. And that's something that Jitendra also spoke about in his presentation. I think that is actually a pretty big problem, interesting problem, and a problem that probably hasn't been fully solved yet, but I think that is definitely the future. I think in this presentation also, Professor Shu spoke about this a little bit. He said that for the fine-tuning and the special situation, dexterity type issues, generated data can be very useful. So you can have a sort of a task, and then the sort of the last mile problem, or in this context, the last sort of fine-tuning can be also augmented with generated video. So to summarize this presentation, robot learning from human data is it's in line with the way we see the area evolve. And I think I just want to say a few things also in general for maybe for new listeners. Why are we even talking about all these things? Here at Orange Capital Partners, we are invested in the robotics pipeline. So this is basically what we're investing in, real-world AI through Tesla and NVIDIA. And therefore, we spend quite a bit of time trying to understand the actual mechanics, the engineering, the problems that the scientific community and the engineering community are tackling. And I think this is a good example of also sort of our approach. Or the purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. And I think this is a good example of literally what it feels like. Like you have to step into uncharted waters, and go, let's say in this case, deep into science, and not to the point where we actually give presentations and go to conferences as presenters, but certainly as spectators to understand what's going on, so we can then frame our thesis and also see what's going on with our companies and whether they are on the right path. And for example, when we invest in NVIDIA, we expect an exponential amount of increase in compute and inference, and that is what drives the NVIDIA business. And we think that this real-world data or the robotics data will generate that kind of demand. As far as Tesla is concerned, I think one of the biggest questions there is of course whether Optimus in principle can be a product that actually generates value. And I think once you see the pipeline and the abilities that are already in place in the scientific community and the engineering community, you can then extrapolate that is maybe something that a company like Tesla could tackle. And then, of course, the big advantage of Tesla is that they also have the scale to produce millions of these robots. Thank you.